Hello, welcome to the video. In this lesson, we're looking at section 3.3, where we're going to look at function notation. So, for many of you, when we look at function notation, can be a little bit, you can be a little bit uncertain. But let me ease your uncertainty by saying that function notation is relatively similar to equation notation. So we were looking at graphs that were linear in 3.2, and we have y is equal to mx plus b. That was kind of the general equation that we were looking at in the previous section. All right. This is an example of equation notation. Because you have two variables. You have your independent variable x and you have your dependent variable y. If we are looking at something with function notation, you are replacing the dependent variable with the function of the independent variable. So instead of writing y, you're going to write in what is called f of x. That is how it is said. F of x is going to be equal to mx plus b. This is the function notation. So function notation saying like f stands for function. They have other names that you could call function, but the most common letter that gets placed in front is f. And then the variable inside of the notation is representing the independent variable. So since we used x on the other side, we use x in with respect to the function notation. Okay. So if you are nervous or you are unsure, just replace f of x with y and solve it the same way. You're going to get the same answer. I'll show you. So here it says they're asking us to evaluate f of x is equal to negative 4x plus 7. All right. So again, if function notation worries you, this is the same thing as writing y is equal to negative 4x plus 7. All right. They mean the same thing. They mean the same thing. So you can use this to help you solve it. So what they're essentially saying is, well, x is going to be 2 and x is going to be negative 2. So if I put here, I got y is equal to negative 4 times 2 plus 7. I go about and solve it. This is going to be y is equal to, what, negative 8 plus 7. So y is going to be equal to negative 1. I go over to the next one. I got y is going to be equal to negative 4 times it by negative 2 plus 7. So now I got y is equal to uh, positive 8 plus 7. So y is equal to 15. All right. So those are your evaluated results. All right. Y is equal to negative 1 when x is 2, and y is going to be equal to 15 when x is negative 2. But since they have it in function notation, what we're going to do is we are going to rewrite it with respect to the function value. And so this is what it's going to look like as your answer. So instead of writing y, you're going to write f of, but instead of writing x, you're going to write down what was x equal to. So x in this case was going to be equal to 2. So this is going to be f of 2. F of 2 is now going to be equal to negative 1. So essentially, this is how you would write it in function notation. If you look at the the next answer, y equal to 15, again, you're replacing y now with f of, and now you use the value that you put in for x to get your answer, which was -2 in this particular instance, and that is going to be equal to positive 15. So that is how they would like you to write it in function notation. Now, if you used function notation the entire time, it would look something kind of like this. So like for this one, it would be, oh, f of 2 is going to be equal to -4 times it by 2 plus 7. F of 2 is equal to -8 plus 7. F of 2 is equal to -1. All right, so that's where we get that same answer as well. Okay, and the same thing would work the out and if you used f of -2 in the function as well. But if you feel more comfortable substituting in with y and solving it from there, by all means go ahead. But again, this is how they want you to represent it as a function as well. Here it says, let f of t be the outside temperature in degrees Fahrenheit, and t is the number of hours after 6 a.m. They want you to explain the meaning of each statement. So here it says f of 0 is equal to 58. All right, well, what was the variable? T. T represented time. All right, how many hours? They're talking about hours. How many hours? 0 hours. So 0 hours after 6 a.m. So to interpret this or explain to this, they're telling us that at 6 a.m. it is going to be 58 degrees Fahrenheit. For the second example, it says f of 6 is equal to n. So they're saying that after, 6 hours, so after 6 hours from 6 a.m., it is now going to be n degrees Fahrenheit. And then for C, it says f of 3 is less than f of 9. So to interpret this statement, all they're saying is after 3 hours from 6 a.m., the temperature will be less than after 9 hours from 6 a.m. And whatever that temperature is, they didn't give it to us, but that's how we interpret that from the function notation. So again, here, this is, they're giving you another set of, another function. In this case, it's at h of x is equal to 2/3 x minus 5. They want you to find the value of x when f of x is equal to -7. So what they're asking you to do is this. They want you to replace h of x with -7. So replacing that, I get -7 is now going to be equal to 2/3 x minus 5. So now we're trying to find the value of x, which is great because it's the only variable that's there. So utilizing multiple step equations, add 5 to both sides. This gets canceled. I get -2 is equal to, rewrite that a little better. -2 is equal to 2/3 x. Then from here, I'm going to multiply both sides by the reciprocal. So cancels here and here. So I'm left with x over here. 3 halves times it by -2 gives me a -3. So x, I just like to put it on the, so x is equal to -3. So essentially when h of x is equal to -7, x is -3. Here they would like us to graph this function, all right? And so this function is y, or f of x is equal to 2x plus 5. Again, you can put it as y is equal to 2x plus 5. That's fine as well. Let's get a graph out. So let's start plotting some points. So I'm just going to make a table. X, I got y. I'm just going to pick some negatives, some positives. So I'll go -2, -1, 0, 1, and 2. So here I got 2 times -2 plus 5. So this is just me inserting that value into there. So that gives me -4 plus 5, which is 1. I got 2 times -1 plus 5. I got -2. That gives me 3. 0. So now I have 2 times 0 plus 5 is equal to 5. You kind of notice there's a pattern here. 1, 3, 5. I'm guessing 7 is the next one, but let's look. 2 times 1 plus 5. Yep, it's going to give me 7. And I bet this one will be 9. So 2 times 2 plus 5, 4 plus 5 is equal to 9. Okay, so I got my ordered pair. So this is -2, 1. This is -1, 3. This is 0, 5. I got 1, 7, and 2, 9. So plot the points. So here, 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 and here. So getting my straight edge, make sure that it hits every line. And that is a representation, a graph of f of x is equal to 2x plus 5. So here we have a graph which talks about, looks like helicopters. It says the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles further and increases its speed by 25 miles per hour. The function is f of x is equal to 350 minus 125x, which represents the second flight, where f of x is the number of miles the helicopter is from its destination after x hours. They're asking us which flight takes less time, and they want you to explain. So we have the first flight here. Looks like it went, looks like they were at 300 miles and it took 3 hours. So first flight, we got 300 miles and the time was 3 hours. So it says which flight takes less time. So they said here, it looks like after, using the function notation, if I were to say x is 0, I would say that the second flight is 350 miles. Now what we got to do is figure out what x is when the flight time for the second flight is at 0. So I got 0 is going to be equal to 350 minus 125x. So let's subtract 350 to both sides. So I got negative 350 is equal to negative 125x. And here I'm going to divide a negative 125 to both sides. So let's see. Negative 350 divided by negative 125. I get x is going to be 2.8 hours. So which flight took less time? The second flight. And that is being able to use function notation. Hope this helps. Till next time.